We're going to begin this lecture with 12.1, which is an introduction to rational expressions. We have just a few definitions to go through and some topics, important points to make, and then we will move into examples where I will actually pull up HOCS and show you what happens in HOCS when we go through these problems rather than writing them as I did in the previous lecture. A rational expression is an algebraic expression that can be written in the form P over Q, where P and Q are polynomials. What's really important here to remember is that Q, or your denominator, cannot equal 0. So remember, we can never divide by 0. An important point to remember here. And as we go through, we're going to end up using that whole idea of not being able to divide by 0 to determine what the restrictions are for these rational expressions. So it's a fraction. I told you before we will be doing lots of fractions, so that's really what we're doing. One of the questions it's going to ask you is, what are the restrictions for this rational expression? When you are asked that question, what it's really asking you to do is set your denominator equal to 0, if there is a variable and solve for the variable. They're having you practice in this particular section on finding restrictions, but as we go through this chapter, it really and truly should be something that you do every single problem. Anytime you have a rational expression or a rational equation as we get further into the chapter, you should always, that should be your first step, figuring out what would be the restrictions for this particular rational. The next topics we're going to cover are some of the arithmetic rules for rational numbers or fractions. You'll find many of these on your formula sheet. So don't forget that formula sheet has important information. And it looks a lot like gibberish when you first look at it because lots of variables. But this is the first one. It says if we have A over B, then that is equal to A times K over B times K, where B and K are not equal to 0. Basically what that's telling you is as long as you multiply the numerator and the denominator times the same number, you have equivalent expressions. Think about when you reduce fractions. So this is one of the important topics, rules to remember. This next one, you need to understand what a reciprocal is. So the reciprocal of A over B is B over A. And when you multiply reciprocals, in other words, when I multiply A over B times B over A, my answer should be 1. And once again, because we have A and B in our denominators, we need to make sure we make the statement that A and B cannot be equal to 0. The next rule talks about what happens when I have two different rational expressions that I'm multiplying together. So A over B times C over D. You just multiply across the top. So numerator times numerator, A times C, and then denominator times denominator, which is B times D. Once again, we have to make the statement that B and D cannot be equal to 0. So the next one's going to be what happens when we're trying to divide two rational expressions. So A over B divided by C over D. Rather than divide, we're going to multiply by the reciprocal. So instead of having A over B divided by C over D, that's going to be equal to A over B times D over C. Now here, we can't have B, D, or C equaling 0. Trying to fix my D and I'm not doing a very good job. It's a little bit better. We have 2 more. We've multiplied, we've divided. Now we need to remember the rules for adding and subtracting. So when I have A over B plus C over B, notice they have a common denominator, then I just add the numerators. So in order to add fractions or rational expressions, you have to have a common denominator. And then you just simply add the numerators. Here, the only thing that cannot be equal to 0 is B. With subtraction, similar idea. You must have a common denominator. So A over B minus C over B is equal to A minus C over B. And once again, B cannot be equal to 0. We are ready to jump in and start the practice. So again, I'm logged into Hawks. I'm in section 12.1, and I'm going to start the practice. This problem says find the restricted values of x for the following rational expression. If there are no restricted values of x, indicate no restrictions. So in this problem, we have 9 over 26x. I'm going to work down here. So 9 over 26x. In order to find restricted values, you set the denominator, which in this case is 26x, equal to 0, and you solve for x. So I'm going to divide by 26. It does not like me to divide by 26. Not sure. All right, I moved it. It doesn't seem to like me to go very far down on my screen for whatever reason. I'm not sure why. So I moved the math up here. So 26x equal to 0 is what we had. So I'm dividing both sides by 26. So x equal 0, which essentially is then what x cannot be because I cannot divide by 0. So what you would type in right here is x equal 0. So I went ahead and typed that in. I'm going to hit submit answer. It tells me I'm correct. That's always a good feeling. So we'll come in here, clear all of our drawings, and we'll move on to the next problem. So in this problem, again, find the restricted values of x for the following rational expression. If there are no restricted values of x, indicate no restrictions. And this time we have negative 5x minus 2 all over 13. So if you remember back on that page that we talked about restrictions, in order for there to be restrictions, there has to be a denominator with a variable. So 13 is just a constant term. It doesn't have a variable. So 13 is never ever going to be able to equal 0. So this is a situation where there are no restrictions. So we will go in and we will fill in the bubble for no restrictions and submit our answer. Let's see, let me go in and clear the drawings. Let's see if that helps. There we go, and hit submit. And I'm ready to move on to the next problem. Here we're asked to reduce the following rational expression to its lowest terms. So when you are reducing, there are just a couple of things that you need to remember. So in order to reduce, you want to factor your numerator and your denominator. And again, I always like to think about what the restrictions are. So I'm probably going to ask you that every time anyway and talk about it, but it's not asking for it in this problem. Remember factoring? We did that in the previous section. We need to look at both our numerator and our denominator and figure out what we can do to factor it. So when I look at my numerator, I have a binomial. It doesn't look like I have a sum of cubes. I can't do a sum of squares. So it looks like always the first thing anyway is GCF. And I do think I have a GCF here, and that's 4. So I'm going to factor out the 4, which is going to leave me with y plus 4. When I look at the denominator, I don't think it has anything in common, so I'm just going to put the y plus 4 down there. And then you're going to reduce or simplify. So when you have things that look alike in the numerator and the denominator, then you can divide those out because they become 1. So I can divide out these two y plus 4s. They become 1, and I'm left with just 4. And so that's what I'm going to type in. And submit my answer. All right, let's move to the next problem. Here we have 7y minus 28 over 4 minus y. Notice there are 2 steps here. Step 1 is to reduce the rational expression to its lowest terms. So I'm going to factor my numerator, factor my denominator, and see what I can reduce. So when I look at my numerator, I have a 7 in common. So when I factor out the 7, I end up with y minus 4. Now in the denominator, these look pretty close. I have 4 minus y. I want y minus 4. So what I'm going to do is factor out a negative 1, which changes the signs, which leaves me with y minus 4. So now I can divide out the y minus 4s, and I'm left with 7 over negative 1, which is just negative 7. So that's what I'm going to type in to the answer box. I'm going to hit submit. I got it right. It's always a good feeling. That's the one really nice thing about HAWQS is the instant gratification, instant knowing exactly what you have or what you don't have right or wrong. So we're going to clear those drawings and go on to the next step. So step 2, it's the same problem. So I'm going to write down for you what we had when we factored, because this time it's asking for find the restricted values of y, which actually I probably don't even need to do the factors. All I need to look at is the denominator. It does have a variable, so I'm going to set that denominator equal to 0, and I'm going to solve for y. So I have 4 minus y equals 0. I'm going to add y to both sides. 4 is equal to y, which really means that 4 can't be equal to y. So down in the box, I'm going to type in the 4. Now I'm going to come up here and clear my drawings and move to the next problem. So this time it's asking me to reduce the following rational expression to its lowest terms. So I'm going to factor numerator and factor denominator. The numerator is a difference of squares, so that's going to factor into x minus 3 and x plus 3. The denominator, the only thing I can do there is take out a greatest common factor of 2, which leaves x plus 3. And now the things they have in common, there's an x plus 3 in the denominator, x plus 3 in the numerator, which leaves me with x minus 3 over 2. And that's what I'm going to type in the box. So when you come down here, you open up your keypad, it's a fraction. So I have x minus 3 over 2, and I'm going to submit my answer. Move on to this next problem. Clear that annotation. Start again. This one's a little different because I don't have a binomial in my numerator or denominator. I just have several different terms all in one monomial. So the first thing you do is you reduce things that are alike. So the coefficients. How can I reduce, I'm going to keep that negative sign out in front. How can I reduce 12 and 8? They're both divisible by 4. So 4 goes into 12 3 times. 4 goes into 8 2. So I have a 3 in the top and a 2 in the bottom. Then the next thing I'm going to do is reduce where my x terms are. So I have 3 x's in the numerator. I have 4 x's in the denominator. So most of my x's are in the denominator, and I have one more down there. When I look at the y's, I have 1 y up top, 2 y's on the bottom. Most of my y's are on the bottom. I have one more on the bottom. So it becomes negative 3 over 2xy. And that's what I'm going to end up typing into the box. Put the negative in, get my fraction. 3, you just hit the down arrow to go to the denominator. 2xy. Submit your answer. Move to the next problem. This problem is asking for us to find the restrictions again. Find the restricted values for x. So I only need to focus on the denominator. My problem is x squared over 6x minus 1. But for restrictions, just focus on the denominator. 6x minus 1 equals 0. I'm going to solve for x, so I'm going to add 1 to both sides. That leaves me with 6x equals 0. Then I'm going to divide both sides by 6. So x equals, well, and I did that problem wrong. We will have to go back. What happens when I add 1 to both sides? This is when it's really nice to have a classroom with people in it and they can tell me I've lost my mind. So plus 1 plus 1. That leaves me with 6x equals 1. So I have 6x equals 1. Then I'm going to divide by 6, divide by 6. X is equal to 1/6. But remember, it's not really, that's the one value x can't be because it makes my denominator 0. So when I go in here and type this in, I'm going to have 1/6. Submit my answer. Move to the next problem. This one looks like it's going to be a little bit trickier. I have a binomial in the numerator and a trinomial in the denominator. So I think I'm going to be factoring both numerator and denominator. This problem is actually just asking us to reduce the fractions, so I don't have to worry about restrictions. But always have that in your mind, because as we move forward in this chapter or this particular course, you're going to need that information. It's going to be a question you're going to be asking all the time. So our rational expression is x squared plus 2x all over x squared plus 4x plus 4. So in the numerator, all I can factor out is an x. That's my common factor. That leaves me with x plus 2. In my denominator, I'm looking for two factors of 4 that add to be 4. So it's x plus 2 times x plus 2. Now I'm going to reduce what I can. So if I look here, I have an x plus 2 in the numerator, an x plus 2 in the denominator. So that leaves me with x over x plus 2. And that's what I'm going to type into the box. X over x plus 2. Submit my answer. I love it when I see a green bar. Let's move to the next one. Find the restricted values of x for the following rational expression. If there are no restricted values of x, indicate no restrictions. So the only thing I need to focus on here, remember, is when it's restrictions, just looking at my denominator. So the rational expression is x plus 6 over x squared minus 169. So I'm going to take the x squared minus 169, and I'm going to factor that. That's a difference of squares, x plus 13 times x minus 13. So now I have two different problems that I'm going to have to set equal to 0. I'm going to have to set each factor equal to 0 and solve. So x plus 13 equals 0. I'm going to subtract 13 from both sides. So for this one, it's x equals negative 13. For x minus 13 equal to 0, I add 13 to both sides, and it ends up being x equals positive 13. And so I have two restrictions for this particular problem. So when I go down and I type into that box, you have a couple of options. You can type in negative 13, comma 13. I also could have used the keypad and put plus or minus 13 in there. It's probably a good habit to get into to do negative and positive, or type both of them out individually, because sometimes your restrictions aren't just opposite numbers. Green bar again. Clear those drawings. Let's see what the next one's going to throw at us. Reduce the following rational expression to its lowest terms. So factor numerator, factor denominator. So in the numerator, I have y squared minus 2y minus 8, no GCF, but I'm looking for two factors of negative 8 that when I add them together give me a negative 2. So that's going to be negative 4 and positive 2. That's my numerator. In my denominator, I have y squared minus 7y plus 12. So I'm looking for two factors of 12 that when I add them together give me negative 7. So that's going to be negative 3 and negative 4. Then I look at my problem and see what is it I have that I can eliminate. And I have a y minus 4 in the numerator and a y minus 4 in the denominator, which leaves me with y plus 2 over y minus 3. So that's what I'm going to type in that box. y plus 2 over y minus 3. And green bar means good. So clear those drawings. Move to the next problem. Reduce the following again. This time we have x squared minus 2x minus 3 all over x squared minus 1. So when I factor the numerator, I'm looking for two factors of negative 3 that give me a sum of negative 2. That will be negative 3 plus 1. And the denominator has x squared minus 1, which is a difference of squares. That factors into x plus 1 times x minus 1. So when I look to see what I can divide out of numerator and denominator, the two x plus 1s will go, leaving me with x minus 3 over x minus 1. Notice when I type it in, I don't use the parentheses. It's a habit when I pull it out of the factored form for me to do that, but it's not necessary when you type your answer in. Hopefully this is clicking for you. Find the restricted values of x for the following rational expression. If there are no restricted values of x, indicate no restrictions. Once again, only need to worry about the denominator. The rational expression is negative 3x over 8x squared plus 3x, but all I need to worry about is 8x squared plus 3x and what happens when that equals 0. First thing I'm going to do is take out a GCF, which is x, leaving me with 8x plus 3. So here is why we factor, because we need to solve things like this. When I'm multiplying two things together and they equal 0, I know that one or both of those have to be 0. And that's the whole reason that we need to factor. That's why it is so important. When you have the product of two things and your solution is 0, you know that one or maybe both of those things are equal to 0. And that's the assumption that you work with. My very first factor is x. That's what I'm going to set equal to 0. No solving necessary there. My second factor is 8x plus 3. I will set that one equal to 0. I do have to do a little bit of math here. Subtract 3 from both sides. Leaves me with 8x equals negative 3. Then I'm going to divide both sides by 8. In that case, x is negative 3 over 8. So my two solutions are 0, negative 3 over 8. I'm going to type those in. I'm going to clear this first, I believe. That'll make it easier for you to see. Zero, comma, negative 8 over 3. And I actually think that was backwards. I believe it was 3 over 8. That might be a problem with clearing my information a little too soon. We'll find out. All right, I got it right. Move to the next problem. This is probably going to be the last example that I'm going to do. I don't want these videos to be exceptionally long. Find the restricted values of x for the following rational expression. If there are no restricted values of x, indicate no restrictions. So this problem is just finding those restrictions, just focusing on the denominator. My rational expression is x squared plus 5 over x squared minus x minus 6. But I only need to worry about x squared minus x minus 6 and what that looks like when it equals 0. I have to factor it. So I'm looking for two factors of negative 6 that give me negative 1. That will be negative 6 positive 1. So the two equations I have to solve are x minus 6 equals 0, x plus 1 equals 0. On the first one, x minus 6 equals 0, add 6 to both sides, so x is equal to 6. The second one is x plus 1 is equal to 0, so I'm going to subtract 1. X equals negative 1. Clean this up a little bit. Type in down here in this box. My two solutions are negative 1, 6. I did something wrong. So let's go back and look and see what happened. Well, it had to have been in my factoring. So let's look and see. How do we check to see if we've made a mistake in our factoring? We multiply it out. What happens when I take x minus 6 times x plus 1? I get x squared plus x minus 6x minus 6, which is x squared minus 5x minus 6. So that's what I did wrong. I factored incorrectly. So if it was not x minus 6 and x plus 1, my only other options would be x minus 3, x plus 2. Let's see what happens when I multiply that out. X squared plus 2x minus 3x minus 6 gives me x squared minus x minus 6. So these are the two I should have used, x minus 3 and x plus 2. X minus 3 equals 0 gives me x equals 3. X plus 2 equals 0 gives me x equals negative 2. Let's see if they like that better. We're going to try again. And this time we're going to type in negative 2, 3, and hope for the best. All right, that was right. That's what I'm going to do to finish out the practice and examples for section 12.1. There are 4 more problems to do. Again, I really recommend that you do every single problem in the practice. That's important. You'll notice if I save and exit, even though I have 4 problems left, let me get in here and clear this annotation. It says I'm ready for the certify because I only had to get 65% of the problems correct in order to do the certify. So it's not that I have to keep going. It's just that I recommend that we keep going. You never know if there was a type of problem that we didn't get to as we were going through that. Now, I've practiced this enough and I know we've done an example of every type of problem, so I know that's not the case, but you don't know that for sure if you're not as familiar with the content as what I am. So hopefully this video helped you. I probably will put up a question to see which one you preferred, if you preferred me going through HOCS or just doing examples that I put on the whiteboard for you. So watch for that, and I hope everyone gets through 12.1 without too much problem. If you are struggling, please make sure you reach out to me. One of the things I didn't show you is that when you're in the practice, there's a send instructor feature. If you get stuck on a problem in practice, go ahead and send that to me and I will make you a video of how to work through that solution. That's a feature that's only available in the practice. I won't work on certifies or help you with certifies. Remember, that's a quiz. Everyone have a wonderful rest of your day.